Hi everyone, welcome to Skilled Inspirational Academy. This is free CCNA Day 7 class. So I hope yesterday we had some glitches with the packet tracer for the Vlan labs. And I have a EVNG topology that's created and we can do the same lab in EVNG today. Let me open up the EVNG lab for you today. So I'll show you the configurations, whatever I have done. Let's do this lab one more time, but I want to show you the connections first. So I have created two VLANs, VLAN 10 and 20. And same thing what we did yesterday in the packet tracer. I've created two VLANs and switch one, the switch, and the second switch. This is switch 2, and I've created the same VLANs, VLAN 10 and 20. But if you actually see the switch 1, I have my, this is switch 1. If I give show IP interface brief, I got two SVIs, right? The VLANs are assigned with IP address. So I got my gateway here. I haven't configured any L3 IP address here. So all my L3 is sitting on the switch 1. So my idea is to, just make a trunk port. This port as a trunk. Just make this port as a trunk. And VLAN 10 and 20 are allowed. Only L2 trunk here. Sorry, L2 VLANs here. I made this port as a trunk. As we discussed yesterday, trunk is, it carries the VLAN information, 802.1Q. So I have to check both ends that this particular, interface is 802.1 capable port. How do I check that? Let me go into the switch 2 and give a command show interface trunk. See this is encapsulation.1Q. I'll show you the configuration inside what exactly I have done. The interface I configured is interface Ethernet 0/0. So show run interface Ethernet 0/0. Switch mode trunk encapsulation.1Q. This is for the pretty old switches. As I told you earlier, by default, if you just give a command, switch port mode trunk in the Cisco switches, it enables the encapsulation.1Q protocol. What is the use of this protocol? This protocol is used to carry your VLAN informations. Inside the Ethernet header, you got your MAC address, and along with an header, specific header where it says 802.1Q. So inside you got your VLAN tagging. As we gave an example, like your outputs, you got a tags in a similar way. Inside the 802.1Q header, you get this VLAN information. The VLANs I have created is 10 and 20. That's tagged inside, and this is sent it across the switches. So the purpose of this port is to carry the VLAN information. Since I made it as a .1Q trunk, whatever VLANs you create, that's been tagged into it, right? VLAN 10 and VLAN 20 in my case. So two information are tagged and send it across to the remote switch. The same way, when I make a trunk on the other end, the same thing applicable there, same concept. The port will be carrying all the VLAN that's created locally on the switch, and for this back to, this forward this packet back on the same port because it's being a trunk port. The same thing I did here. We have to enable encapsulation.1Q because this is, this is IOU image. this is used only for testing. This is not in production environment. So this is pretty old command, I would say. So now if you just give switch port mode trunk, that's equivalent command that enables .1 queue. Both does the same job, but here I'm manually explicitly giving this because this is not auto trunk capable. This is manual trunk capable. This is auto trunk. That's a key difference. It is an interview question. They say, how do you sorry, how do you do a manual trunk and auto trunk? So from the output I can see, so interface trunk 802.1q. But I think yesterday, if you have seen that the mode it says auto, but here it's manual trunking because I have enabled this command switch mode trunk encapsulation .1q. Let's move on then. So what are all the VLANs I have locally on this switch? So I got VLAN 10 and 20. And this VLAN 20 is assigned to port Ethernet 0/1, and I haven't assigned any port for VLAN 20. I don't have any PC for it. So this is the PC that's on VLAN 10. Let me go and show you how to assign an IP address in the VPC. This is VNC devices. This is something it behaves like a virtual PC. You can assign the IP address with very limited functionalities. All you can do is you can make use of this to assign an IP address for testing. That's purpose of this VPC. So let me close all this VPCs back to we have to track this VPCs. So I'm going to open one by one, and let's do a renaming. If I click on this PC, it opens up. And if you give a question mark, you will get a help where you can, specify your name of the VPC, the very first command, to differentiate, right? So let me give set and the VPC name. So let me give it as switch to test. You can make use of this command. I think hyphen is not allowed. Set switch to white such says an invalid command. Set host name and echo options. Set the host name VPC to a name. Okay, let me give PC name then. Right, working problem. I think there is two ways to assign a name. PC name, and I have to give PC name followed by test. It's question of for him. Okay, let me give set. Set PC name switch to. Okay, so this is a command set PC name followed by the name. Switch to, let me give switch to test. It's too long, so it's not allowed. So let me just give it as a SW2. It makes us a switch. So let me give it as a PC switch 2. Okay, so just to differentiate, so this is a PC connected to switch 2. So the same command I'm going to give for other devices. Open this, set PC name. So this is PC1, switch 1. So this is my PC2 and switch 2. PC2, switch 2. Okay. So how do I check the IP address that's assigned? So let me go here, show IP. So I haven't assigned an IP address. So let give help. How do I assign an IP address? IP followed by this is on. Let me go back to the switch and check the port configuration. So on switch 1, give a command show IP interface brief. So what is the port? It's connected Ethernet 0/2. This is the port that goes to the first PC. So what is the command I've been running on this port? It should be an access port. I click and give show running interface. Running interface Ethernet 0/2. So I made it as an access port VLAN 20. So what is my gateway? 20.0.0.1. So I'm going to assign an IP address in this range. It's going to change the PC2. Let me go to PC1, switch 1. This is Ethernet 0/0. Show IP. I haven't assigned an IP address here. So IP help command. IP followed by the argument, right? So IP, and I'm going to give 10.0.2/8. The default gateway is 10.0.0.1. It's checking for the duplicate IP address. So I have set this IP. So let me try to ping the gateway. Host unreachable. Go to the switch and check the config. Show IP interface brief. It's 10.0.0.1. And what is the subnet mask I've given? Show running interface VLAN 10. The same subnet mask I'm using for this PC also. The gateway is 10.0.0.1. So how do I verify the port? So let me go configure interface Ethernet 0/2. It's where the PC is connected. I'm going to shut down this port. State to down. Let me give no shutdown. Let me show packet table. It's just showing me Ethernet 0/0, only the trunk port, not these two ports. So I'll go ahead and do a delete this device. Let me go edit. Okay. So this is the device it's connected now. Let me go delete this device and add a new device. Add an object node, virtual PC, save. Stop this. Delete. To add this device. Stop this switch. Okay. So Ethernet 0/2. So I'm going to the switch 1. So switch 2. So I'm going back to switch 1 here. Let's turn on this device. Started. So let me open the console of switch 1. Enable. Show IP interface brief. My configurations are saved and show run interface Ethernet 0/2. So this one access VLAN 20. Okay. For my better understanding, let me go mark the ports here. So this is for VLAN 20. VLAN 20. Let me give a name for this switch. So this switch, let's make it a switch 1 PC1. How do I do that? Let me go to VNC, open VNC. Set PC name. Switch 1 PC1 assigned. And the IP address should be on 20 network. So IP 20.0.0.5. You can give any values from right from 1 to 253. More than that, the /8. So you got about 2 power 24 minus 2. Got as many as IP address. I'm giving 20.0.5. And the default C area value subnet mask is /8. And the gateway is 20.0.0.1. Checking for the duplicate IP address. Okay, I'm done. Let me try to ping 20.0.0.1. Okay, I get a reply, right? So my connection is fine. Let me go back to the switch 1. Okay, this is up and running. So I got my gateway. So I have to make a same config on this device. Open this VNC. This is PC2. Okay, cancel. I got the connection already. PC2, switch 2. Show IP command will show me the IP address that's been assigned. So, okay, I didn't assign an IP address at all. Okay, what is the IP address I should give here? I have to jump into switch 2 to see the port configuration. Enable command, privilege mode, config mode. So before that, I have to check show IP interface brief. if you actually see, I didn't assign an IP address at all. That's subjective. See, without, yesterday, I believe somebody, they said we need an L3 switch in the middle. No, it's not this two or just an L2 image. Actually, see, this is an L2 image. I'll show you inside. So version. This is Cisco developed, and this is L2 image, L2 capable switch, not doing L3. Get done. And then what else? I have to check the ports. Go to switch 2. Now, what is the port that's been assigned now? Let me give show MAC address table. Okay, this is 20.0.0.1 and Ethernet 0/0. I'll explain about this MAC address. How do we learn 2 MAC address on a single port? Now I have to check a connection for this PC, this VNC PC. So this is PC2 switch. So let me assign an IP address, and what is the port I have configured? Show VLAN command will show me the assigned ports. Just an Ethernet 0/1, and that's on VLAN 10. Ethernet 0/1. Go back to my VPC IP 10.0.0.10/8. Gateway is 10.0.0.1. So the gateway, I just configured the gateway, the switch 1. It's not in the switch 2. Confirm again. Show IP interface brief. See, this particular IP has been up and running on the switch 1. Right. So I got 4 tabs. This is switch 2. If you actually see, I haven't configured anything here. So if I try to ping from this PC 10.0.0.1, it should work, right? I can ping. Say I am on PC connected to switch 2, right? All I got is a trunk in the middle. Yesterday we tried with the same lab. Here I got VLAN L2, VLAN 10 and 20, along with L2 VLANs, and along with that L3 VLAN 10 and 20. What is L3 VLANs? It's capable of assigning IP address to it. So I got my L3 IPs assigned to this switch. I have only the L2 VLANs. So what happens? It's something you can imagine. It says, hey, I got a trunk. So it means what? Whatever the VLANs you create here, VLAN 10 and 20, just an L2 VLAN. Here, no routing happens, right? So your VLAN 10 and 20 traffic is being tagged to this trunk port and send it across to the switch. So I believe it should be some kind of limitation with the packet tracer. I'm not sure about that, but that's not working in the packet tracer lab. But the same configuration I did in the EVNG, it works. So the understanding is the key. I mean, here I just have my, I got the L2 VLANs, not L3 VLANs, only the L3 VLANs, or sitting on the switch 1. But due to this protocol 802.1q, that's actually tagging this information VLAN 10 and 20 and sending this across the trunk port. So once the switch receives this, so say, hey, what is the details you have sent it to me on the trunk? Okay, VLAN 10 and 20. I'm aware about that because I created these 2 VLANs. So this packet is coming back to the switch, this gateway, right? Because this PC is coming with what information? It says, hey, I am from VLAN 10. The VLAN 10 and 20 is allowed. So the packet is forwarded back to the switch. Since this is a gateway, so I have to reach this device. So how exactly the IP communication happens? If I am 10 or if I am on a 10 network, I don't know how to reach the other networks. It just sends a packet back to the gateway, right? So this is directly connected to the switch. So I know about VLAN 10 and 20. So the packet will be forwarded back to this switch. And let's come back to the outputs. Let me go to the switch 2 and erase this, make it clean. Show interface trunk. Can you see this? This is very important. In the output, when you're in production network or if you're deploying any switches, you have to focus on this 3 key points. So one is native VLAN. So we'll discuss about that. What is native VLAN? So 802.1q. Now we are aware that this 802.1q is capable to forward all your VLAN traffic from A to B. So here in this specific port, if I enable this encapsulation, whatever VLANs you created, 10, 20, 30, 40, if it goes on, it tags all this information with this protocol. This protocol is specifically designed to carry the VLAN information to the other switches on the remote end. And what are all the VLANs that's allowed? That's showing me it's 1, 10, and 20. 1 is by default, it's native VLAN. VLAN has binary forwarding state and not prune. Prune is what? That's blocking, filtering. So this is not filtered. So all this VLAN information has been sent it across this link. The output, you should understand what is the meaning of the output. Every single output and the details inside the output you should be aware of. Just doing a trunk, you won't understand much. You should understand all this. This is very important in the production network. So be focused on all the outputs, whatever you see, you try to understand. Okay, so I made a trunk and all that. So now we'll go to native VLAN. So what is native VLAN? So we all aware about the VLANs now. I believe we got better understanding VLAN than before. So what is native VLAN? In early back 90s, I would say 80s, there is a device called a hub. Maybe you guys would have heard about this hub. This is just, they call it as an L1 device. All it knows is just broadcasting. If a PC is connected here, if this PC wants to communicate to this PC, say this is a ABC, for example, if the PC A wants to send a packet to PC B, the hub is not intelligent like switch. It just says, hey, I don't know about, I'm not bothered about that. Okay, you want to send a packet, I broadcast this out of all the ports. So if this PC C wants to communicate to other device, it has to wait until the communication, until the communication between A and B has to be stopped. Otherwise, the communication between A and B, how it should be interrupted. So I'm intended to say, if there is a break if there is a communication break, or if there is no communication, only then the C can communicate. So this is called a half duplex. It can send or receive a data one at a time. It cannot send and receive data simultaneously. But in switches, it's not like that. If the 2 PCs connected, 2 or 10 PCs connected, all the 24 PCs can send and receive traffic simultaneously. Send and receive can happen at the same time, but whereas in the hub, it's not like that. The PC has to wait until the communication breaks or the communication has been ended between 2 endpoints. That's a major drawback of hub. So nobody is using a hub. So what is native VLAN? See, I got a switch. Say, for example, I got a hub. By default, native VLAN is VLAN 1. So what is the purpose of VLAN 1? So we discussed about tagging, right? So inside this tag, this is very important. Please listen this. See, inside the trunk port, I got VLAN 10, VLAN 20, and VLAN 30. All these are tagged information. Everybody agree? But whereas this native VLAN is untagged. This is an interview question. They would ask, what is the use of native VLAN? If I connect a hub in a switch, will the hub is intelligent enough to understand what the switch is sending the traffic? We should say, yeah. It will understand the native VLAN information. What is the native VLAN? It is untagged. What is mean by untagged? That is open. That's not coming up with any specific tagged information. That's just like an L1, just a broadcast. So by default, if you have a switch that comes with native VLAN 1, it can communicate. You no need to define your ports to, just connect the port and it starts working in the real world. Because that's nothing is tagged inside. So if you connect a hub, and if you configure something like by default, as I told you, native VLAN is 1, and if you have assigned an IP address like 10.0.0.1 and you made a gateway in this switch with an IP address 10.0.0.1, this hub is going to receive this traffic and forward this traffic back to the PCs connected to it. But whereas if the switch is sending VLAN 10, 20, and 30, the hub is not intelligent to understand the tagged packets because it's not capable to understand .1Q protocol. It's going to drop all your VLAN 10 and 20 packets. Only it forwards the untagged packets, that's native VLAN 1 here, for example. So you can connect the hub, and if the native VLAN information will be forwarded and the hub can understand, because there's nothing tagged inside. I don't need any protocol to run to understand all the VLANs because I am open and it's just a broadcast L1 device, not intelligent like switch. That is hub and native use of native VLAN. And you would come across, this is a, use case. If you have a switch here, both switches, if you have native VLAN 1 by default in both switches, you don't have any problem. But if you change the native VLAN to 2, native VLAN 2. So why do I want to do this? I want a hub connected. And my requirement here is, this VLAN 2 is the VLAN that's dedicated for the hub. The user, they are working, they are connected here. So being a network engineer, I have to decide what VLAN should be broadcasted out. So here I want to make this native VLAN 2 should be sent it across to the hub. So how do I do that? I will change the native VLAN to 2. So what happens now? By default, the native VLAN 1 that will be stripped away, and the VLAN 2 will become a native VLAN 2, and the information will be forwarded back to the hub, and the user receives an IP address and it makes a communication on VLAN 2 only because I made native VLAN 2. You can customize your VLANs. By default, it comes with native VLAN 1. Let's try to change the native VLAN inside the switches now. Enable show VLAN. Default VLAN is Ethernet 0/0. And how do I check my native VLAN? Show interface trunk command will show me the native VLAN information. Here it says VLAN 1. So how do I change that? Configure interface Ethernet 0/0. Switch port trunk native VLAN. Here I'll create one more VLAN for testing, like I'll make it as VLAN 30 as a native VLAN. Let's see we see any errors, because in the other end, show logging. So I'm getting any errors. Let me go back to switch 2. So show interface trunk. So here is native VLAN 1. So in the trunk now, the native VLAN here in the switch 1, it's 1. And if I give show interface trunk, the VLAN, can you see this? There is a native VLAN mismatch. Why is that? Because I got a native VLAN 1 on switch 2. I changed this back to native VLAN 30 here. So let's try. If I make changes on switch 2, the switch should not throw this errors anymore. So let me go inside the trunk port interface Ethernet 0/0. Switch port trunk native VLAN 30. What happens now? Show interface trunk. So here a question for everyone. If you know the answers, you can ping your answers in the chat. But it's a CDP is a layer 2 or layer 3 protocol. You can post your answers. So now I am not seeing any errors, right? Because if I give show interface trunk, the native VLAN I have changed from 1 to 30. So I don't need a trunk port actually to carry this VLAN information, because by default, the native VLAN 30, that's untagged information, untagged traffic. So let's try this. The packet tracer would be faster than this. Let's do that. So this is what I want you guys to, I want you guys to understand. All I have the gateway configured in switch 1, not in switch 2, but still I have a communication. All I need is a trunk port in the middle. It forwards this information. That's just pretty simple. If you go for the, inter-VLAN routing and packet tracer, I believe we should have a L3 switch, and you got an L2 switch, and your PC is connected, and all your gateways L3 SVIs should be configured on layer 3 device on the top. But in the production environment, it's pretty simple. If the switch is capable of, if you can configure the interface VLANs with a trunk port in the middle, it just sends a packet out. All you need to have an 802.1q capable trunk port. And we discussed about native VLANs, right? Let me try to do a lab in packet tracer for native VLAN. Cancel this. Stop this. Let me open up packet tracer. Cisco.com. Let me log in this packet tracer. Logged in. Okay, I'm already logged in. What happened to my login failed? Sorry for that one. Let me try. My Google account. Okay, I have a successful connection now. Let's try now. I have a switch. Let me quickly do this. Do I really have a hub? The packet tracer. I got a hub and I got a PC connected to it. And got my endpoints, PCs, two PCs for testing. Take my lightning bolt. Okay, since you guys are familiar with this packet tracer, I'm going a little bit fast. Close this. Zoom in a little bit. Enable, configure. Let me create VLANs, VLAN 2 for testing, and interface VLAN 2, IP address 20001, 25000, and then one PC on VLAN 2. Okay, and I want to change the native VLAN here. Okay, let me keep the default VLAN to show you exactly. Show VLAN. We discussed about changing VLAN, so default is fine. But I want to make this port as a trunk. Configure interface fast Ethernet 0/1 switch port mode trunk. So what happens now? I've connected two devices. So my layer 2 is up. Okay. So IP interface brief. But my protocol, okay, protocol is also up. I didn't get any IP address, but still up. Okay. So let's try now. So I got a VLAN 1 by default, right? So configure interface VLAN 1, IP address 10.0.0.1, 255.0.0.0. Yeah. Let me go to this switch because this is no VLANs here. Let me try to configure the IP address quickly. So for this fast Ethernet 0/1, I'm going to give 10.0.0.1, 255.0.0.0. Okay, sorry, this is assigned to gateway. Let me change this. 10.0.0.1 is my gateway. So 10 network. Let me open up PC 0. So let me assign this to VLAN 20 to 20.0.0.1. Done. What is the IP address assigned here? 10.0.0.2. Let me try to ping 10.0.0.1. Request timed out. I think I should have one active device connected to it, right? Show IP interface brief. Can I say this? This is manually down. We paste the no shutdown. Now the interface changed up. Show IP interface brief. Okay, my protocol and okay. So if I ping, can you see this? Why I can ping? Post your answers. So yeah, you guys have to be more interactive. I like people to interact with me because only then I can, I mean, I feel that you guys are getting what we are learning here. Ask your questions, no problem. You can ask in the chat and we'll have a Q&A session. But I'm so excited to, get answers from you. But how can I ping 10 minutes of this? I made this as a trunk, right? Show interface trunk. You see this 802.1q, it's trunking. And my native VLAN is 1. So it proved. So the theory, what I learned about native VLAN, it makes sense, right? Because the native VLAN here, what happens in the 802.1q, you got two traffics. Let me differentiate with colors. So this is your VLAN 1, native VLAN. For that, the hub is not intelligent, but it's receiving this packet because VLAN 1 is untagged. Whereas here, VLAN 10, right? Let me check quickly. I think it's VLAN 10 or 20. Show IP interface brief. VLAN 2, sorry. So VLAN 2. So my VLAN 2 is tagged. Let me try if I can, I can ping 20001 from this PC. No port configuration, just an L1 device. Ping 20001. I cannot ping. Why? Because I cannot understand trunk. The hub is not intelligent to understand the trunk. It's trying to send the ICMP request, but it's failing because the package is dropped in the hub. It cannot forward the tag traffic. So that's the concept of native VLAN. Okay, so let's jump into, so we got 802.1q, native VLAN and trunking. We talked about that and we did the lab for 802.1q. And let's jump to DHCP. So in all your broadband connections at home, right? Let me open up a whiteboard. Create a new whiteboard. Okay. So in your home broadband, all in one device that works as your router, your switch, and your modem. Why? To convert your analog to digital. You need a modem for sure. So all these three features being embedded into one single device, that's your broadband router. You're connecting your PCs, you're connecting your mobile phones, you're connecting your laptops. All this connection is wireless. But how do you get an IP address? Are you going inside your mobile phone or your laptops to assign an IP address? No. Auto IP assignment. How this happens? How this broadband router knows that, okay, he is in need of an IP address. That's where the DHCP protocol comes in. Two key things here. Inside your DHCP request, you get your DNS. You might heard about the DHCP process, but DNS that's been embedded with your DHCP. Okay, let me erase this. So this is a PC. So this is your DHCP server. So what is DHCP? Dynamic Host Configuration Protocol. In all the network terminologies, whenever you learn about protocols, you just imagine it's just the rules. If a dynamic IP assignment has to happen, I need a rule. What is the rule? That's DHCP process. So what are the steps that's carried out in the DHCP flow? I got a PC, right? I want an IP address. So inside your PC, you made this PC to get an IP address automatically. Auto IP assignment. I'll try to show my NIC card. Can you see this IP address auto assignment? DHCP. Only because of this, I get the IP details. Let me go edit. If I make it as a manual, I lose the connection now. I'll be dropped out. Let me try to check the adapter setting. Additional properties. Edit. Okay, all I get is here. I should see a network adapter. I take my Ethernet port. Actually, they changed a lot with Windows 11. How do we get my NIC card? Okay, so here is my NIC card. Let me go to properties and then go back to internet properties. Can you see this? I cannot say anything here. I mentioned my IP address to receive an IP address automatically from the DHCP server. So who is my DHCP server? My broadband router. But in the enterprise, it's not the same way, right? Because the DHCP server, it's one centralized server. It does only the job of DHCP handout. How this actually works, all I do is I just want to select an option to get an IP address automatically. That's it. Boom, I get an IP address. As simple as that. So there is no, human intervention needed. I don't want to configure the IP address. I don't want to be aware of the network gateway. All I have to give is just obtain IP address automatically. Guys, maybe you guys may know about this DHCP, but my focus is to teach everyone in the class. Maybe they are beginners, so I'm trying to make it interactive for them as well. Let me go back to the whiteboard to explain the DHCP process. So now we have seen how to assign that. There is two type of NIC cards in your PC. Generally, mostly you would have one is your wireless NIC and the Ethernet NIC. Ethernet NIC is your wired connection, but most of us, we are not using it. We get used to wireless. I don't want to be hooked up my PC with wired connection. I have to roam around anywhere. But when you hook up your PC, you have to be idle in one place. But when your PC is connected to wireless, I can roam around anywhere. Sorry. So there is two types of NIC cards. So inside the NIC, the IP address will be sitting inside the NICs. So the one which I shown you, can you see this connection? This is a wireless connection. So everybody might know this, but what is inside this NIC? That's your IP assignment. Once you got all these IP parameters, only then you can talk to your network, irrespective of your tablet, your PCs. It should be on the same network only if I get an IP address. So who is giving this IP address? That's the purpose of DHCP server. In my home broadband connection, I'm always referring to home broadband because you guys love, using it daily basis. So this works as a DHCP server. So what is the purpose of DHCP server? It got a pool, network pool. Say for example, 10.0.0.0, subnet mask is 8. And it got a gateway, right? 10.0.0.1. So for the very first time, when you boots up your PC from your wireless NIC card, they call it as a DORA process. This is to remember better. I'm just giving this, but DORA is discover. It's the first message the PC will send. Hey, discover my DHCP server. Where is it? That's the first packet that goes from your PC. Discover. For this discover is a broadcast. Do I know my DHCP server? No, I don't know who is DHCP server. I don't bother about my DHCP server. I don't know about that. But it just sends a broadcast. Discover is always a broadcast message. Broadcasting is what? Hey, everyone, listen to me. Who is the DHCP server? So once the DHCP request has been received, because this particular PC is connected to your wireless network, your broadband connection, this DHCP server will reply back. It will offer, hey, I'm offering your IP address. Just like if you book tickets, you get a ticket from your IRCTC website, right? The same way, you're just trying to find a list of IP address, but there you can define your tickets, but here it's not like that. Hey, give me an IP address and my DHCP server is offering IP parameter details. So it's offering the information. What are the information? Hey, this is my gateway. This is my gateway. You have to reach to me 10.0.0.1. And the valid IP address 10.0.0.2. This is your valid IP, and this is my gateway. You have to communicate to me because you are in my network. This is your usable IP. It offers this information. So it would say, you can send discover message if there are two DHCP server. Here comes request. So it's my priority. Hey, I'm just ignoring your IP address and I want to rely on this second DHCP server. So that's how the offer comes in, request. So it sends a discover and it sends a discover will be sent from client. It sends an offer message with all these IP parameters. And it sends a request. Okay, I agree with IP details. I'm ready to get 10.0.0.2 and your gateway is 10.0.0.1. And it says, then it receives the request. The DHCP server will reply back to this PC with an acknowledgement. Okay, I agree, you get this IP address. This is the whole process of DHCP. See, just learning DHCP is discover dynamic host configuration protocols never going to help for you. This understanding is very important. This is crucial. You have to understand. So there are 4 handshakes happens: discover, offer, request, and acknowledgement. Yeah, that's it, guys. That's for today. I think I want to give you a clear explanation about every topic. That's it for today, and we'll continue tomorrow with the remaining topics. I hope today everybody would have understood all this DHCP process, and we had some glitches with the packet tracer study, communication between two L2 switches and VLANs. I hope now it would be clear. Any questions? You guys are most welcome to ask your questions.
Hello.
Yeah.
Sir, good evening. Tell me about something about Aviva versus DSCP.
Okay, Apipa versus what like, you have an idea what is Apipa? Any idea about Apipa?
Yeah, D-
What's your understanding
when
about?
DHCP fails,
Sorry.
when the DHCP server fails,
Mhm.
the PC automatically assign one IP address that is called the APIPA.
Automatic private IP address assignment, right? Automatic private IP assignment. That's the full form of Apipa, right?
Yeah,
That's automatic IP assignment. Okay, here is a question. So you got a DHCP server and it's down. So you get an Apipa IP address, or you get an IP address from the DHCP.
APIPA only.
Why?
Because
Because
the DHCP,
yeah, go ahead.
here the DHCP server failed, so the PC cannot get the IP from the DHCP, so it will automatically assign one IP.
Yeah, great. Yeah, because for my discover message, for my broadcast, there is a specific timeout, right? It has to wait maybe for 30 seconds. Example, if I'm not getting any reply for my discover, it's going to send the IP address automatically. That's Apipa. And here is a question. See, you got your switch and you got your two PCs connected, and two PCs are assigned with Apipa IP address. The DHCP server is down. Will these two PCs communicate?
Yes, it will communicate.
Great. Great. Yeah, that's
Uh,
correct.
mm,
The Apipa IP address range, if the both PCs can communicate, because they are on the same network. That's correct. Your answer is correct.
It's happening only in Windows or Linux.
Linux, the workstations, I do not have much experience with Linux. I have to check, but in Windows, by default, the operating system itself, they have this feature, Apipa. Automatically, the OS will assign the IP address
I
to
am
it.
also weak from OS, so I think it's only a window-based facility. Might be.
Okay, sir. I have to check on that. I'm not sure about that, sir. I'll check on that and definitely I'll answer
Sure, please,
the
please.
question tomorrow. Sure,
Thank you.
no problem. So I hope everybody understood today. I think today's class is informative and you guys would have enjoyed. So if there is no questions further, I'll close this session.
Sir, I want to show my screen because I have done yesterday practical.
Okay.
Grant me the permission, sir.
You can share your screen. I mean, I think no limitation for sharing your screen. Is it something saying that you cannot share? Who can share? All participants can share. Okay. Summarization. Try now.
Then you want to stop your screen share, then only you can share.
Is it?
Yeah.
Oh, okay.
Now you can share.
Share your screen, please.
Yeah, look into this.
Uh-huh.
It's connected now. I want to do practice again.
Uh-huh.
Just hold on. And I am dialing the number.
Mm-hmm.
First one is 54002 and second one is 54001. I'm
Okay.
dialing this one 54001.
Yeah, you're receiving your call. It's working.
Now it's connected.
Yeah.
But I'm facing some issue
Uh-huh.
for the, let me show. Um, it's my network architecture.
Okay.
It's a
Okay.
router and it's a switches and it's IP phone. But
Mhm.
I'm not, I am not able to separate. It's a, it's in same VLAN. I want to configure the different VLANs. So it's also in VLAN one. It's also in VLAN one. It's got IP.
Show your switch. Show your switch configuration for the ports. One minute. Go back to the. Go back to the packet tracer main window.
This one.
Yeah, and try to enable the labels. That would be easy for you to track.
How to enable label?
You go to tools. Sorry, options. Go to options.
Options. So
Options. Preferences. Yeah, and here you use labels.
where is it?
There. Yeah. Down, little bit down. Fifth option. Yeah.
This,
Check this. Top. Yeah.
this one?
Yeah. Yeah. Closest.
Yes. Thanks.
Yeah. Open your switch. Move your window a little bit right side. A bit right. Let me see the port.
All right.
No. Can you move it a little bit right?
This one. This side.
Yeah. Right side. Right side.
It's okay.
Yeah. That's fine. Yeah. You sure run? Yeah. There is nothing you configured inside the port 3. Can you see fast Ethernet 0/3? Fast Ethernet 0/3. Go top.
So that's why.
See fast Ethernet 0/3. You haven't configured anything here. The top. No,
Okay.
you configured for fast Ethernet 0/15. It's supposed to be fast Ethernet 0/3.
Yeah. This one. This one.
Yeah. Come down. What is your port configuration? What is your port configuration? Come down. The port configuration you have done, right? Where is it? Nothing. See, in the access port, I told you, right? What is switch port? Access voice VLAN.
Yeah.
So the same command you have to see. You connected this IP phone. IP phone is just like a bridge, so it's up and running. You have to run the same command that's inside fast Ethernet 0/15
Okay.
inside fast Ethernet 0/3. Only then you get a connection.
Okay. Okay.
You try to change the configuration on fast Ethernet 0/3.
Okay.
Do the same configuration what you did on fast Ethernet 0/15 on fast Ethernet 0/3. You would have a successful connection.
Okay. Okay. Got it.
Yeah. Okay, sir.
Thank you. And anything,
Okay, no problem.
now in router, any
You can stop sharing. Router, go back to router. No, router is not needed. You have to give that command and it works.
basically I want to configure two DSCP server on router one.
Okay.
One for voice
Okay.
and uh, one for VLAN 100 and one for VLAN 200. VLAN 100 for the voice traffic and VLAN 200 for the data traffic.
Then you have to configure DHCP pool, two DHCP pools
Yes.
with two different names, and configure the networks accordingly. Then you
Can I
will have
find the
your
can I,
DHCP server running.
can I assign the two IP addresses on single port, single interface?
Yeah. That is possible using a sub interface.
But no. Basically, I have tried secondary with the word secondary, but it's not taking.
No. Secondary, see, you have to understand one thing. Secondary, assigning IP address in a single port with two primary and secondary. If your primary is down, only then the secondary will be functional.
Okay.
Right, until the primary is functional, it will not pick the secondary IP address. So you have to create a sub interface, logical interface. Since the router got one interface on your router, you have to go and create a sub interface. Might be in the recording labs, you can see how I'm creating the sub interface.
Yeah,
We'll get,
I'll check.
yeah. And do that and get back to me. If you have any difficulty, then get back to me.
Sure.
But try with the sub interface. It's the interface fast Ethernet 0/0.2. Just give it .2 and give an encapsulation .1Q VLAN 2030 whatever you want, and create the same VLAN in the switch. Then you have your VLAN communication between switch and router, and you can assign an IP address. Then create two DHCP pools, one for voice and one for data. It works.
Okay. Thank you.
Yeah, no
Thank you.
problem. Okay, guys. Anything else? Let's wind up this session. Okay, thanks. Thanks everyone for joining today. We'll catch up tomorrow. Have a great day.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Arjun.
Thank you.
Thank you. Bye.